Example 2 asks us um, finding different values for unknowns and trying to figure out what we can about the roots given different parts of an equation. So it says we have a quadratic equation and it is x squared minus k times x plus k plus 3, and that equals 0. And it says that it has two real and equal roots, where k is a constant. So two real equal roots. So what this is telling us is that we have this equation. We don't know what's going on, but the additional piece of information that they give us is going to help us, and it's going to really lead us to getting this answer correct. Well, two real equal roots. This is the same as having just one, right? It's the same answer to a quadratic equation for both possibilities. When we think back, this type of solution set for a quadratic comes about when the discriminant of our function equals 0, if you remember from the previous example. So what this means is that b squared minus 4ac equals 0. This is our discriminant again. That's what that means. If you see a problem that's similar, that's telling you something about the roots of a quadratic equation, something about the nature of them, we can use the discriminant to figure this out. So b squared minus 4ac equaling 0 is very, very helpful because now we have something to use to help figure this stuff out. So now what we need to do is figure out what our b, our a, and our c are. Well, our a term comes from x squared, so we have a is going to be 1, right? Now b is whatever term is attached to x, whatever the coefficient is. So b, in this case, is negative k. Right? So whatever is being multiplied by x. So there may be a time where you might have to simplify or do something in order to get the exact coefficient of x, but in this case there's only one x, there's only one coefficient for it, and that's negative k. So b equals negative k. Now we have this k plus 3 left over. K is an unknown. We don't know what it is, so we can't add it to 3. If you had 3 plus 2, you could simplify that. 3 plus 2 is 5. But what is k plus 3? It's just k plus 3. That's all we know. We can't simplify it any further. So our c value, our constant, is actually k plus 3. So now we have our a, we have our b, we have our c, and we know that b squared minus 4ac equals 0. So what we are going to do is we're going to use that. We're going to say, okay, well, if our b is negative k, and our a is 1, and our c is k plus 3, that has to equal 0. So now we have an equation. It's not simplified, but we have an equation that we can use to go and find what's going on, and we can use this to find out what our k can be in order for this to work. So we're going to need to simplify. Negative k squared is the same thing as k squared. Now, keep this in mind. Negative k squared is not negative k squared, right? Negative k squared is the opposite of k squared. That's what this means. Opposite of k squared. This here is negative k squared, right? That whole quantity, the opposite of k squared, as opposed to the... It gets kind of confusing, sorry, but just keep that in mind, that squaring a term that is inside the brackets versus squaring a term that is outside of brackets can be different if the sign's different. So now we have 4 times 1 is 4, so we have 4 times k plus 3. So we still need to simplify. We're going to have k squared minus 4 times k is 4k. The negative 4 times the positive 3 is going to make a negative 12, and that will equal 0. Well, at this point in time, we have several different options that we can use in order to solve this. This is a quadratic equation in itself, so we can think about factoring, we can think about completing the square, we can think about using the quadratic formula. All of those are options. They're all decent options for this. I like to factor. Whatever version you want, this is up to you, however you want to solve it. So from here, I'm going to break this up because I want to factor. And I need to say, okay, well, I have two binomials. That's what factoring a quadratic equation is going to do. It's going to generally give you two binomials. And so we say, okay, well, what two numbers are going to multiply to make negative 12 that are going to add to make negative 4? Interesting. Now, that simple thought process that I just said is a lot easier because there's a coefficient of 1 in front of k squared. It's going to be different when that doesn't happen, but we will cover that later. So two numbers that do that are going to be negative 6 and a positive 2. Right? Negative 6 times positive 2 makes negative 12, and if you add them together you get negative 4. And from this we have something very interesting, right? We have a quantity k minus 6 times a quantity k plus 2 equals 0. Well, there's something called the zero product property, which says that if you have a series of things being multiplied together, and if all of those things that are being multiplied together equal 0, then that means that if any one thing that is being multiplied by anything else is 0, then it will work. So what we can say here is that if k minus 6 was 0, it doesn't matter what k plus 2 is, because k plus 2 could be any number, but 0 times anything makes 0. So we know that that can be true, and that will work. And that's what we're looking for. We're looking for the numbers that are going to make this thing work. And having 0 on that one side of the equation is really awesome, because now we can use this property, which is very, very helpful. And then finally, if k plus 2 is 0, if that is 0, then it doesn't matter what k minus 6 is, the whole thing will work. And these are the only two possible ways it can happen. We can't get 0 any other way from a product than one of the products being 0, or one of the parts being 0 and the other part being 0. So now we can say if k minus 6 is 0, then we know that k has to be 6. And if we know that k plus 2 equals 0, then we know that k has to equal negative 2. So these are our two possible values for k. The second part says, hence, for the smaller value of k found in A, so our smaller value is negative 2, find the roots of the equation. Very interesting. So what we're going to do is, so k is negative 2. So what that means is our equation would be x squared minus negative 2 times x plus negative 2 plus 3. And that equals 0. Well, we want to go ahead and simplify this because we're trying to find what the roots are. We want to know exactly what they are. So we're going to get x squared. This will be plus 2x. And then a negative 2 plus 3 is going to be a positive 1. And that will equal 0. So now we can, again, we have this equation. We have it down. So we can choose any of those methods I talked about. We can factor, we can use the quadratic formula, or we can do completing the square. In this case, I'm going to do factoring again. I prefer it. So we're going to set up our binomials. Again, it's very, very easy because there's no coefficient of x squared, or there's just a coefficient of 1, excuse me. So now I need two numbers that multiply by 1, or multiply to make 1, that add to make 2. And so this is going to be positive 1 and positive 1. And so that would mean, kind of like we talked about earlier, either x plus 1 equals 0 or x plus 1 equals 0. And so we know that from that x would have to equal negative 1. That's the only way that this works. So based off that, now the k for being 6 would have some sort of different option. That can happen when we have some unknowns, but we used the idea that they gave us at the beginning of two real and equal roots. And we said, okay, well, if that's true, then we have to know, we know that we can use the discriminant to find that, because the discriminant would equal 0 if there were two unequal roots. And that's even proven down here. By using -2 plugged back in, we see that we end up with two roots that are both -1. And so that's what our answer is going to be.